Hello! Today we're going to be going through y equals mx plus b. We've gone through this before in the last unit, but again, it's just one of those where at the beginning of units I like to go through things again just to make sure everyone is okay. So here we go. So, just a quick starter. This is from last lesson. Have a look, see if you can do it. Okay, so if we recall the slope then, just very quickly, slope is what we consider something called rise over run. So let me just zoom out because for some reason the pen won't spawn unless I do that. And then we can zoom back in and then the pen exists. Good, lovely, love this, awesome. Let's try one last time. Okay, so the slope then. The slope is rise over run. So what that means is you basically make a triangle between two nice points, you find out how much it went up, you find out how much it went across, you divide those numbers, and that's what you decide the slope is. This is what the slope is for everything, including even real life. When people talk about the slope of ramps, they're literally talking about how much does it go up for every how much it goes across. And obviously some ramps are really like not as steep. We want that, for example, for people in wheelchairs or whatever, so they can go up the ramp. So same word used incredible amounts. It's also used when you might see, if you ever go up a steep hill, you might see a signpost that says, oh, slope is this number. Also used in skiing. So it's all the same idea. This is just obviously used for graphs. So as I said, what we're going to do is we're going to make a triangle. We pick two lovely points on the graph, and then we literally go, how much did we go up? How much did we go across? So here's a point, here's a point. And we know they're lovely points because I can read their x and y coordinates, right? I don't pick a point like, for example, here, because I've got no idea what the x and y coordinate is there. Okay, so then we draw a triangle, we see how much it went up, so it went up by 1, we see how much it went across, we go across by 2, right? Because it went from 2 to 4, which is 2, and it went from 1 to 3. Be very careful, don't just try count the squares, because sometimes the axis has like, instead of having 2 and 4, it might have 2, then 4, then 6, then 8, and it goes up in like multiples of 2 and multiples of 3. So we can't just count the squares, we have to count actually what happened in the axis. Okay. So, as I said, slope is rise over run. So in our case then, that's going to be 1 divided by 2. Simple as that. Yeah, because 1 is the rise, 2 is the slope. For this one, it's going down. So no matter what, I instantly know my slope's going to be negative. Up, we go positive. Down, we go negative. Again, pick two nice points. It really doesn't matter where it is. Draw a little triangle. What's it done? It went from 7 to 3, so it's going down negative 4. It went from 1 to 3, so it went across 2. So then you just do rise over run, which is negative 4 over 2, which again, you can just say is negative 2, can't you? Because negative 4 divided by 2 is negative 2. You can also just completely ignore the negatives for a bit if you want to, and then just put the negative at the end. Let's be brutally honest. As long as you know the line's going down, you know the answer is negative, so you just don't even have to worry about this being a negative 4. You can just say it's 4, and then go 4 divided by 2 is 2. That means it's negative 2 because it's going down. Cool. If we had coordinates, what we do is we actually go, okay, you can either draw these, so you can use any kind of software, like Desmos is wonderful for that, or you can just find out what's happening with x's, right? You can find out what's happening with the x coordinates, find out what's happening with the y coordinates, and then just do y divided by x, right? Because y is the rise, x is the run. So if we look at the y, or the rise, or whatever, let's call it rise as well. If we look at the y, we can see it went from 4 to 10. So if I do 10 take away 4, that gives me 6. That's my rise. If I look at run, which is also my x values, it goes from 2 to 5. So I do 5 take away 2, which is 3. So if I then do rise divided by run, I do 6 divided by 3, which is 2. But again, you can actually plot these and then draw a triangle if you'd prefer to do that. What about this one? Same idea. My rise then, it went from 7 to negative 2. So I'm just going to do negative 2 take away 7, which is negative 9. My run, it goes from 7 to 8. That's what? It goes from 5 to 8. So I do 8 take away 5, which is 3. And so then negative 9 divided by 3 is just negative 3. Cool. So we can do it with graphs. We can do it with coordinates. We can do it with, I don't know, pandas. You can do it with whatever you want as long as you're comfortable. And again, if you are not 100% comfortable doing it with coordinates, there is nothing stopping you having a graph, plotting the points, and then drawing the line and then drawing the triangle. There's nothing wrong with that. I'm trying to show you that you don't always have to do that if you don't want to. Okay, so a quick recap then, a quick recall of everything we should have learned last unit. I hope maybe let's talk about it. I don't know, let's see. So When I say that x equals 0, that's the y-intercept, right? So in other words, if we go back a second, it's where it crosses the y-axis, right? So when x is 0, the place where the line crosses the y-axis is the y-intercept. So this one is 9, this one is 0, right? So y-intercept is when x equals 0. It's where the line crosses the y-axis. The x-intercept is when y equals 0. So it's where it crosses the line in the x-axis, right? Slope, we just talked about this, is your change in y over change in x, or your rise over run, because rise over run is easy to remember. This is more like a grade 10 kind of conversation. We have different kinds of slopes. We have slopes that go up. When you read left to right, that's positive. We have slopes that go down. They're negative, left to right again. A zero slope, i.e. it literally doesn't have any steepness at all, go straight across, that one makes sense. And then undefined slope, which literally is a wall. Right, it can't be defined. And again, we spoke about this before, about because the run is basically 0. Well, it's 0, isn't it? The run doesn't move. And when you divide by 0, you don't get a number. Like try it in your calculator, it'll either come up with error or undefined. So if in any test or whatever I say, hey, here's a line, what is the slope? Undefined is an absolute perfect answer. There is nothing wrong with that. It is a mathematical term. So it's okay to use that. Okay, equation of a line then. So equation of a line is always in the form, well, we can write the equation of a line in the form of y equals mx plus b. I would say 90% of lines come like this. M is the slope, so whatever this number in is the slope. We've just done a bunch of that a second ago. The number goes here. And b is that y-intercept that we just spoke about, where it crosses the y-axis. So for example, y equals 3x plus 2 has a y-intercept of 2 and a slope of 3. Y equals 5x minus 1 has a y-intercept of negative 1 and a slope of 5. Y equals 3 minus 2x. Notice how the 3 is the number on its own, so that is your y-intercept. Negative 2 is your slope, because with the x. So be wary here, right? Because it should be in the form y equals mx plus b, but there's nothing wrong with this. It's still an mx plus b, it's just we put it in the wrong order. So just be careful there. It's the number with the x that's the slope, number on its own, that's the y-intercept. Cool. If we were going to find the equations of the line then, we'd just do everything we've just basically done, but we do it just for lines. I don't take everything. Again, I've got to zoom out, press the button, zoom in. Lovely material. Okay. Here we go. Yep, lovely. So we pick two nice points. Doesn't matter where they are as long as they're on the thing. We find the slope by drawing a line. Again, look at the axis. What's happened on the bottom? It went across 2. What happened from 3 to 7? It went up 4. So my slope is 4 divided by 2, which is 2. My y-intercept, where does it cross the y-axis? Well, it's right here, isn't it? Yeah, it's at 3. So my y-intercept is 3. And so the equation of my line is y equals slope x is 2x plus 3. Cool. What about this one? Again, instantly I can see that my slope's negative. Let's pick two nice points, there and there. Draw a triangle. How far did it go across? It went across 2, from negative 3 to negative 1. How far did it go down in this case? From 7 to 3, it went negative 4. But again, you can leave the negative off if you know 4 divided. You know the answer is going to be negative because it's going down, right? So anyway, my slope here, slope is negative 4 divided by 2, which is negative 2. My y-intercept, I'm not writing the whole thing, I'm just going to call it y-int, is going to be 1, isn't it? So then my equation of my line is y equals negative 2x plus 1. Or you can be cheeky and say 1 minus 2x if you really want to. I just keep the negative 2x there because why not? Okay, so hopefully that makes sense. I've got all that in writing as well for the actual one. Yeah, cool. If the slope's not easy, i.e. it's not a whole number, that's still okay, right? So for here, I've already drawn the triangle, right? It doesn't really matter that it doesn't really matter that it's not a whole number. No one cares, right? This slope is going to be 2 divided by 3, right? That's still fine, right? You can just leave it as a fraction. I recommend leaving stuff in fractions because if you put it in a decimal, it's going to mess around, like it's not very nice. For example, I don't really want to write 0.666666x. I don't want to write that. I want to write y equals 2 over 3x, right? So for this one, it doesn't really matter. The y-intercept is still 1. The rise is 2. The run is 3. So my slope is 2 over 3. So my equation of our line is 2 over 3x plus 1. Same idea. Nobody cares that it's a fraction. It's okay. Okay. Last thing that we're going through before you have a go. Just a quick reminder then. If the thing goes across, it doesn't have a slope. So effectively, that would be y equals 0x plus 3. And because 0x is just 0, all I get is just y equals 3. And because this one is y equals 3, because it goes through y at 3, this one is x equals 2, because it goes through x at 2. And all of the coordinates for x are 2, isn't it, right? Like this is 2, 2, this is 2, 4, this is 2, 6, 2, negative 4. All of the x coordinates are 2. So we say, okay, this one's x equals. So x equals 2, y equals 3. Let's talk about it. So it has no slope, this one. Every y coordinate is 3. We call it y equals 3. This slope is undefined and has no y-intercept. Every x coordinate is 2, so x equals 2. Okay. As we said, some lines are weird. No matter what happens, the x value or y value stays the same. All horizontal lines, the x value changes, but the y value doesn't. So we just call it y equals a, where a is whatever number it is on the y-axis. All vertical lines, right? Horizontal go across, vertical go up or down. All vertical lines, the y value changes, but the x value doesn't. So we just call it x equals whatever that answer is. So again, this one here, for this for a, it goes through consistently all the y values and all of these places are 3. So we just call this one y equals negative 3, not 3, sorry. For this one, for b, all the x values are 2. So we call it x equals 2. Those are the weird ones though. Okay, so last few examples, and then you're going to find the equation of some lines. Here we go. So what does y equals 3 look like? Y equals 3 goes through y at 3. So we draw a line straight across at y equals 3. What about y equals 5? Does that change it? No, that can also be read actually. Y equals 5? No, it goes through y at 5. So that's y equals 5. What about x? Let's call these ones. What about x equals 2? You go to the x-axis, you go to 2, and you put a line that goes straight through it. Because all the x values are 2. What about 6? X equals 6, you go to x, you go to 6, so all the x values are 6. You get the idea. One last one, because I don't want to keep going. What about x is negative 6? Oh no, it's negative. Does that change? No, it doesn't. No one cares. X equals negative 6, go to x, go to negative 6, put a line through it, and you win the day. That's it, x equals negative 6, that's it, done. Okay, so there are 6 lines here. Yep, there are 6 lines there. Find the equations of the lines, and then I'll go through it in like 10 seconds. Okay, so let's just try and zoom in a bit. Yeah. Okay, so this one, I can see that the slope, let's pick 2 points, I don't know, here and here. I can see it goes across 3 and up 1. So then my equation of my line is y equals 1 over 3x, and then the y-intercept is positive 1, so plus 1. For this one, I can see that's a nice point. I can see, is that a nice point? Yeah. Let's draw a triangle. It goes across 2, goes down 3. So my equation of my line is y equals negative 3 over 2x, goes through the y-intercept at 2, so plus 2. What about this one? Oh, it's a straight line across. I remember those. It goes through y at 5, and all the coordinates of y is 5, so y equals 5. What about this one? Again, can you see how the coordinates, the axes are a bit weird here, so we're starting to step it up to like a different level, I guess. Just pick 2 nice points, so I don't know, here and here. It goes across, not 2 squares, it goes across 4, from 0 to 4, right? So it goes across 4. And then it goes from 4 to negative 8, so that's minus 8. So then my slope is negative 8 divided by 4, which is negative 2, right? So slope equals negative 8 divided by 4, which is negative 2. So the equation of my line is y equals negative 2x plus, what's the y-intercept? It's 4. What about this one? Pick 2 nice points. I can see 2 nice points and they happen to be on the axis, and you'll find that I normally do this anyway because I just think it's nice. Anyway, what happens here? It goes from negative 8 to 0, so that's positive 8, and it goes from 0 to 6, so that's 6. So my slope is 8 over 6, or 4 over 3 if you want to simplify it. So the equation of my line is y equals 4 over 3x minus 8, because the y-intercept is negative 8. And then last one, horrible graph. Pick 2 nice points, I don't know, there and there. Let's draw a triangle. How far did it go across? It went from 0 to 8, so that's 8. How much did it go down? It went from negative 10 to negative 15, that's negative 5. So my slope is negative 5 over 8. The equation of my line then is y equals negative 5 over 8x minus 10. Cool. Okay, hopefully that was it. Hopefully that made sense. Let's move on. All right, for these questions, it tells you the slope, it tells you the y-intercept, and it wants you to write an equation of the line and then graph the line. Well, the equation of the line is very easy, isn't it? Right? The equation of the line is just going to be y equals 2 over 5x minus 4, or y equals negative 4x plus 5, or y equals negative 2. You can write y equals 0x, but what's the point, right? So that part's easy. And then let's color them in. So let's do this red, and then I'll color them as we go. So remember, it tells you it starts at negative 4. That's what it says. That's what b is, right? So you always start here on the y-axis. So I'm just going to put a dot there. The slope, remember, it's rise over run, right? Rise over run. So it means for every whatever I go right, I go up this number. In our case, then, I'm going to go right 5 and up 2. So I'm quite literally going to count 5 dots across, 1, 2, 3, 4, 5, and count 2 up. 1, 2, and that's my big dot. And I'm going to do that again, 1, 2, 3, 4, 5, 1, 2. And once I've done it enough times, I can kind of see where my straight line will be. So it's going to look something like this. 1, 2, 3, 4, 5, 1, 2. Like this. I want to say like that. But you'd use a ruler in an actual test, right? So this one's A. That one's the red one. What about the next one? Again, we know where to start. We start at 5 on the y-axis. And then we have a slope of negative 4. Oh, no, that's not a fraction. Oh, no, it's not a fraction. That's okay. Just make it 1. Every number can be written as a fraction by putting it over 1. So then, for every 1 I go right, I'm going to go up negative 4. No, wait, that doesn't make any sense. Up negative 4. Oh, I go down 4. I go down 4. So I go 1 right and down 4. 1, 2, 3, 4. I go 1 right and go down 4. 1, 2, 3, 4. Hold on. 1 right, 1, 2, 3, 4. 1 right, 1, 2, 3, 4. And after you've drawn enough points, you can see where your line will be. You draw your line, and you win the day. That's a new saying I've been saying today, isn't it? I don't know. That's the orange one. And then last but not least, we'll do this as, I don't like the green colour, blue. Y equals negative 2. Very easy. It goes through y at negative 2. It's a straight line across, isn't it? Oh, it started off as like the straightest line I've ever done. No, it's not. Okay, and this one's blue. Okay, so hopefully that makes sense. It tells you where to start on the y-axis. It tells you how to draw the line. Just count, and then you're good to go. Have a go. So there are eight questions there. The green ones are the easy ones. The red ones are the hard ones. I've put them on independent pages if you want to have a go, well, if you print this page as well. So we'll go through all these together. And then, sorry, I just went the wrong way there. So if you want to have a go at these, I'll leave these up if you want to just have a go at all of them. I don't know how you're working. And then we'll go through each one very quickly on the other pages. Okay, so the first one, slope is 2, y-intercept is negative 4, right? Remember the slope of 2 means actually slope of 2 over 1. Over 1, I can't write it that accurately. That's supposed to be at 1. So we're going to start at negative 4, and then for every 1 we go right, we go 2 up. 1 we go right, we go 2 up. 1 we go right, we go 2 up, etc., etc. And a line looks like this. Yeah? You should draw your lines forever, ever. You should also technically have arrows on at the end because it's telling the people that it goes on forever, ever. Some teachers really care about that. Some teachers don't. I don't know who your teacher will be next year, but just letting you know I'm trying to help out. For this one, y-intercept is 4, so let's put a dot on 4. It says a slope of negative 3. Remember, that is negative 3 over 1. Negative 3 over 1, which means for every 1 I go right, I count down 3. So I go 1 right, 1, 2, 3 down, 1 right, 1, 2, 3 down, 1 right, 1, 2, 3 down. It's going to look something like this. I've got an update coming, that's awesome. For this one, let's do orange. Y-intercept is negative 1, let's put a dot there. Slope of 0.5, if you know 0.5 is 1 over 2, that makes it much easier. But if not, you could have made it 0.5 over 1, and if every 1 you go right, you go up 0.5. Instead, I'm going to go right 2 and up 1. So we go right 2, up 1, right 2, up 1, right 2, up 1, right 2, up 1, and we get the line looking like that. Cool. And then last but not least, let's go back to blue. No, I guess we'll have to use black. Slope of -1, y-intercept of 0. So y-intercept 0 is here. Slope of -1 is -1/1. So we're going to go 1 right, 1 down. So 1 right, 1 down, 1 right, 1 down, 1 right, 1 down, etc., etc. It looks something like that. Cool, that's the black one now. Hopefully that made sense. Next page. These ones, apparently they're harder because we have fractions, but I actually find the fractions easier. I don't know about you, but here we go. So first one, y-intercept is 2. Slope is 1/3, which means I'm going to go 3 to the right and 1 up. So I go 3 right, 1 up, 3 right, 1 up, 3 right, 1 up. Ignore the fact I just said white instead of right. It looks something like that. Use a ruler, I can't. For this one, y-intercept of 1, let's put a little dot there. Slope of -3/4. Just a quick talk about this. -3/4 can be written as -3/4. It can also be written as 3/-4, but I don't want to do that. So what this means is I can write for every 4 I go 3 down. So for every 4 I go right, I go 3 down. For every 4 I go right, I go 3 down. And it looks something like this. That's probably not straight. Whatever. You get the idea. For this one, y-intercept is -3, -3, and then put a little dot. Slope is 2/5, which means I go 5 to the right and 2 up. So 1, 2, 3, 4, hold on. 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2, 3, 5, 1, 2. So it looks something like that, I believe. And then last but not least, it's got a slope of -1/2, which again is 2 across and 1 down. And it's got y-intercept of 0. So I go 2 across, 1 down, 2 across, 1 down, 2 across, 1 down, etc., etc. And it looks something like that. Okay. All right. Last thing. Oh no, I'm pressing too many buttons. Last thing. Given each equation, state the slope, the y-intercept if it exists, and graph the line. So I mean, we're just it's literally basically everything we've done, just putting it all together. So just a quick recap of all these things then. Let's do the slope in red, and let's do the y-intercept in something else. So the slope for this one, so slope is 1/2, right? The slope for this one is -3. The slope for y = 3 is 0, because it's going to look a straight line like that. And then the slope for x = 0 is undefined, right? For the y-intercept, orange I guess we'll do. The y-intercept, the y-intercept is -5, the y-intercept is 2, the y-intercept for this is 3, the y-intercept for this does not exist, NA, doesn't exist. If I draw them very quickly, right, the first one, I start at -5, and then for every 2 I go right, I go 1 up. So it looks something like that. I'm not going to draw the whole line, I can't bother. For the next one, I'm going to start at +2. For every 1 I go right, I go 3 down. 1 right, 3 down. 1 right, 3 down. Looks something like this. For y = 3, I guess we can use green. For y = 3, it goes through y at 3, so bada boop. And then for x = 0, there's already a line there. Is when x is 0 is when it goes through the 0 on the x-axis. So it looks like that. It goes straight through the y-axis. This one here. Okay, hopefully that made sense. Have a go at the last page, last 2 pages. I don't know if you want to. What I'll do is I'll post the answers up on OneNote, not OneNote, up on the hub with these, just to make sure you got them right. Or you can type into Desmos, I don't know, it's up to you. But that's it, that's the end of the lesson. I hope you have a glorious day, glorious weekend if you're watching this on Friday, glorious whatever. Have a good day, I appreciate you.